Hello, welcome everyone to Professor TK the Chemist, and today I'm going to explain to you guys a fun way to explain what colligative properties are. Okay, let's get into it. So you're probably wondering, how do you understand the Van Hoff factor, which is a curly shaped eye? Let's talk about that for a moment. The Van Hoff factor tells us how many particles a solute produces when it dissolves in a solvent. So solute, solvent, think of a solute like salt, sugar, little crumbly granules, okay? When you add a solvent like water, alcohol, rubbing alcohol, things of that nature, the two can combine together. If the solute dissolves in the solvent, you will have them ionizing into various particles. However, when we get to statement number 2, bullet point number 2 says, determining whether a solute has a Van Hoff factor depends on the type of solute and its behavior in solution. So we're going to get into that also. And number 3, understanding the Van Hoff factor helps predict colligative properties like freezing point, depression, boiling point, elevation for various solutions. Are you ready? Let's get into it. Number 1, ionic versus molecular solutes. Ionic solutes involve those that dissociate into ions when dissolved in water or other polar solvents. Likes dissolve likes. Remember that. Likes dissolve likes. Okay, say it with me. Likes dissolve likes. So examples, sodium chloride, barium nitrate, potassium chloride. The Van Hoff factor equals the number of ions formed. So when we look at sodium chloride, for instance, we see sodium that dissociates from chlorine. Therefore, with one sodium ion, one chlorine ion, the I, or the Van Hoff constant, is equal to 2. When you look at barium nitrate, for instance, right here, let me go ahead and draw it out so you all can see what I'm talking about. You've got barium nitrate, okay? You'll notice how it breaks up into barium, one ion, and then you see the nitrate, which there's a 2 there. The 2 plus the 1 gives us a Van Hoff constant of 3. The 2 plus the 1 gives us 3. Speaking of molecular solutes, these do not dissociate into ions. They stay intact as molecules in solution. So some examples are like glucose, ethanol. The Van Hoff factor for molecular solutes is 1 because they do not split into multiple particles. So just remember, if they are molecular solutes, the Van Hoff constant is equal to 1. Numero uno, numero 1. Bullet point number 2, strong versus weak electrolytes. Strong electrolytes completely dissociate into ions in solution, like sodium chloride, hydrochloric acid, potassium hydroxide. 1 is equal to the total number of ions produced, okay, or the little I, rather, is equal to the total numbers of ions that are produced. So for instance, if we look at the example that we have here with magnesium chloride, you have magnesium. The magnesium ion is just the 1, okay? And then you have chlorine ions, but there's 2 right there, okay? You see the subscript of 2 means that there are 2, and there's a -1 charge for chlorine. So that's 1 plus 2. That gives us the I factor equaling 3. See how simple this is? Easy peasy, right? Let's continue. What about those weak electrolytes? Well, they partially dissociate in solutions, producing fewer ions than predicted by their formula. So if you have like acetic acid or ammonia, the I is less than the number of ions indicated by the formula because they dissociate, their dissociation rather is incomplete. Okay? Statement number 3, non-electrolytes. These substances do not dissociate into ions at all. So again, you have examples like glucose or urea. Their Van Hoff factor will be 1 because only the molecules themselves are present in solution. And number 4, the very last concept that you need to know about how to understand the Van Hoff factor is that when you have solvents and conditions, you have 3 things that you need to focus on. The first one being polar solvents, like water. They favor dissociations of ionic compounds, increasing the Van Hoff constant. Nonpolar solvents like benzene do not allow significant dissociations. So their little Van Hoff constant will be equal to 1 for most solutes. And finally, dilutions. At higher dilutions, electrolytes are more fully dissociated. So the little I approaches the theoretical value. Now, to do a quick check for Van Hoff factor, if it's an ionic compound, then yes, you will calculate the I based on the ions produced. If it is a molecular compound, then the I is equal to 1, unless it ionizes in the solvent. And finally, if it's a weak acid or a weak base, you're going to check the extent to which the dissociations will estimate to be whatever it is in that particular case. All right, so you know it's practice time. I've got my handy dandy pen. Let's get into this first problem. So your instructions are to rank the following solutions from the highest boiling point to the lowest boiling point, elevation. Assume all solutions are aqueous and the boiling point elevation constant is the same for all, okay? So here we go. If we look at the first example, it doesn't matter how much you have of each in terms of the molality concentrations that you see, but what does matter are whether or not they will ionize or dissociate in terms of their process. So if you take a look at the first example, sodium chloride, we know that sodium will ionize or dissociate into their individual ions. So I have 1 sodium ion plus 1 chlorine ion. That gives me 2. So the I, or the Van Hoff factor, is 2. For K2SO4, I have 2 potassium ions. That subscript tells me 2 with a K plus, and then we have 1 ion of SO4. So 2 plus 1 gives us 3. And then glucose, well, that does not ionize or dissociate, so therefore this is equal to 1. So when we actually go through and rank them, we're going to put from the highest to the lowest boiling point. The highest boiling point is letter B, followed by letter A, then letter C. So the higher the Van Hoff constant, the higher the boiling point. It's that simple. Look at number 2. You've got MgCl2. So you have 1 magnesium ion, and then you have 2 chlorine ions. So 1 plus 2 gives you 3. For sodium chloride, you have 1 sodium ion plus 1 chlorine ion, so the Van Hoff constant is 2. And for this last one, urea is automatically equal to 1 because it does not dissociate in its aqueous solution. So therefore, when we look at ranking them, letter A is going to come first, followed by letter B, then letter C. All right. You try the next examples. All right, so I'm going to do number 3 with you, but I'll leave number 4 and number 5 for you to do on your own. And on the next slide, you'll see the answers that you can check yourself with. So for the first one, again, you have KBr. I have 1 ion of K plus 1 ion of Br. So together I have 2. For sodium sulfate, I have 2 sodium ions because of that subscript of 2 that tells me 2 with a sodium plus 1 charge. That's 2 sodium ions and then 1 unit of SO4 of the sulfate ion. So 2 plus 1 is 3. And then finally, glucose is equal to 1 because it does not dissociate in water. So therefore, you're going to end up with letter B having the highest boiling point, followed by letter A, and then letter C. It's that simple. You do 4 and 5, and then when you're ready to move forward, you can check your answers. Have a good one, and stay tuned for the other videos that will give you further examples of all the tips and tricks that you need to learn for your next chemistry quiz or test. Take care, and thank you guys so much for joining me. Make sure you share, subscribe, and like this video. And don't forget to tell a friend where Professor TK the Chemist is at. Thank you.